Hey guys, last lesson of the week. You so excited? Me too. You got this. We did 2 weeks in isolation. You will survive. All right. So R is really just so we're gonna do trig form of points. You guys all know rectangular form. It's always x comma y. It's this right here. It's that pretty Cartesian coordinate that you guys already know how to plot. In trig form, this is the same idea because you're going to write x and y just slightly differently. So this time you're going to have an r and a theta. R is going to be the radius, which is really just the length of the line. And then theta is going to be the angle with the positive x-axis. All right. So now if we did this one, we're going to go over 1, down 4. So it's this point right here. And we already know how to do the sine and cosine, so let's go ahead and do that. We draw the line from the origin to the point, and then we draw our cute little reference triangle. It's this triangle right here. So we can already label some of those sides fairly easily. We know this is 1 long. We know this is 4 long. So then we use Pythagorean theorem to find that last side. So you do 1 squared plus 4 squared equals c squared. So then we'd have 1 plus 16 is 17 equals c squared. So then c just equals the square root of 17. So this is just the square root of 17. Perfect. So then sine, so remember this is where theta is. So this would be my opposite. This is my hypotenuse. This is my adjacent. Actually, I feel like I should do that in a different color. Adjacent, opposite, hypotenuse. Okay, so sine is going to be opposite. So we've got to remember this. And we'll need this one as well. So sine is just going to be opposite over hypotenuse. So this is going to be 4 over square root 17. And then cosine is going to be hold up, my brain's not working. Cosine is going to be my brain. Okay, adjacent over hypotenuse, 1 over square root 17. Got this. Okay, it's been a long week. Long week. Okay, so we have 4 over square root 17 and 1 over square root 17. You can use either one of these to help you find the angle. So I'm going to use sine because it's my favorite, but it doesn't have to be your favorite. It can be whatever you want. So sine is just going to be the sine. We're going to use sine inverse of 4 over the square root of 17. If we do that, we're going to get our angle. Now, depending on what you're using will depend on if you have your angle in degrees or radians. So I'm going to use Google. Well, actually, I'm going to use this. And it's going to give me my answer in, we're going to do radians. Because it's in radians right now and I don't want to change it. So we're going to do sine inverse. And you can use Google for this. Of 4 divided by the square root of 17. Oh, I meant that to be outside of there. Okay, and I hit enter. And I get 1.325817664. I'm going to do something and you can either follow along. I'm dividing by pi because remember how pi is almost always part of my answer. I'm going to see if it's a nice pretty number. It's not. Okay, so then our answer is 1.326. So that's how many radians. But remember, these are all positive numbers, right? So that would be 1.326 of my reference angle. So now I need to take 2 pi and subtract that. So I'm going to use my handy dandy calculator and do 2 pi minus, I want this number right there. And I now know that it's 4.957. So my angle, so theta, equals 4.957. Now I had to do all that extra work because this is not the angle with, this is not this angle, because I want to know this angle here. So this is that angle. All right. So now trig form of a point on the coordinate plane would be this. You're going to take your length of your hypotenuse, so square root 17, and x value is just going to be square root 17 times, and then we're going to do the sine, nope, cosine. Cosine's x, sine's y. Notice that one x, 4y, so cosine is x, sine is y. Okay, so now we do cosine of 4.957, and then the other one is going to be the square root 17 sine 4.957. And if you actually type that into your calculator, which I will go ahead and do, so if I do the square root of 17 times the cosine, outside of the square root, come on, times the cosine of 4.957, I should get really, really close to 1. Do you see that? And then if I take this, and there is a reason why I'm doing this. There is a reason. We'll find out tomorrow, like next week, but there's a reason. And if I do this sine time square root 17 times that, see how we get really, really close to -4? Notice that they're all both off by the point, like, amount that I was rounding. Rounding error is a thing, guys. Remember when you get things wrong and it's because of rounding error? Yeah, it's a thing. Okay, so there's our trig point. Trig form. It's really just taking our x number and writing it in a different way. It's taking our y number and writing it in a different way. Now, these will be important. They will be applicable. Just right now, it just seems like a whole lot of extra math. Okay, so let's go ahead and try this one. So if we do sine of theta, so first off, we need to find all of this information. So we're going to go over 3 down 2. 1, 2, 3, 1, 2. So this point right here. Okay. And I'm going to draw my lines, connecting it and making it my pretty little triangle. So then I know that this length is 2 long. I know that this length is 3 long. So then we would do 3 squared plus 2 squared equals c squared. And we get 9 plus 4, so we get 13 equals c squared. So then c just equals the square root of 13. So then the sine would just be, so this is the square root of 13. Sine is going to be opposite, so this is theta. This is my reference angle. Remember, it's not my angle. My angle is this right here. Remember that? And this time I think I'll do degrees when I do the angle, so I'll switch my calculator. All right, so then if we're going to do sine, that's going to be 2 over square root 13. And then my cosine is going to be 3 over square root 13. Notice that the 3 is coming from the x, so my cosine relates to my x. The 2 is coming from my y, so my sine relates to my y. All right, so we're going to do trig form. So the first thing we need to find, so we already have the square root of 13. So I'm going to have the square root of 13 cosine something, and then I'll have square root of 13 sine something. Sound cool? I love this stuff. Yeah, it's fine. I know I'm a nerd. It's fine. Okay, so we have 3, 2, theta, square root 13, all these things. Okay, so what we're going to do is we're going to now use inverse. I'm going to do inverse sine again. So we're going to do sine inverse of 2 over square root 13. So I pull out my handy dandy calculator, and I'm going to switch my mode. So now I'm in degrees. So I want sine inverse of 2 over the square root of 13. And I get that we're about 33.69 degrees. So I know that theta is about 33.69 degrees. Notice this time I put degrees. Okay. So then here I would put 33.69. 33.69. Okay. This last one, I'm just going to leave it in. I want you guys to try this one. If you haven't paused the video yet and tried one on your own, try this one out. Although change it. So, because right now it's 3, -2. So I'm going to change this. I'm going to get a much thicker marker. Yep, that works a lot better. I'm going to change this so that it is. Let's move it into a different quadrant. So let's do. Oh, that is way too thick. Gotta go back to my white marker. So let's do -3, 4. Some of you noticed it just kind of cheated myself, but it's fine. Okay, so we're going to go -3 up 4. 1, 2, 3, 4. Now, if you haven't tried one on your own yet, please try this one out. If you have, it's good practice anyway, so you might as well try it again on your own. Okay, so now I'm going to draw my triangle. Notice that my reference angle is right here. This is not my theta with the positive x-axis. That would be this angle here. So I will need to find that angle. And I forgot to do that over here. Let's go back and do this one. So if you haven't already noticed that I already screwed this up. So right here, I'm going to take 360. So then we take 360 minus 33.69. And we get 326.31. That's the angle that should be there. All right. Back to this one. Yeah. I need a nap. All right. So then this would be 3. Nope. This would be 3. This would be 4. And using Pythagorean theorem, we'd have 3 squared plus 4 squared equals x or c squared. So then we would get 25 equals c squared, and we get c equals 5. Why? Because I made it that way. All right, so then we get 5 right there. So our sign is just going to be 4 over 5, because this is our theta for here. But we want to end up knowing this, so I'm going to call that x. So then we will have 3 over 5 for our cosine. Now, please note, again, I'm going to point it out again, this 3 is the x value. So my trig form, I'm going to write it actually below my trig form. So my trig form would be my length times the cosine of my angle, which I don't know yet, then my length times the sine of my angle, which currently I don't know. So now I'm going to do inverse sine. If you wanted to, you could totally do inverse cosine, or you could totally do inverse tangent. It doesn't matter. So I'm going to do inverse sine of 4/5. And I'm going to use my handy dandy calculator. So I'm going to do inverse sine of 4/5. And I'm in degrees again. Okay, and I get 53.13. Now, this is that many degrees away from that. So I'm going to take 180 and subtract the 53.13. 180 minus 53.13. And we get 126.87 degrees. So I get 126.87 degrees. Okay. Do you have any questions on this? If you do, please leave them in the comment section, okay? Now we're going to switch gears into complex numbers. And I adore complex numbers. I know you guys don't super love them, but we're going to find trig form of complex numbers. And I love that about trig because this form actually makes multiplication of trig numbers easier. And it makes division a lot easier, taking complex numbers to powers, it makes that so much easier. So like when you move them into, it'll be called, so there's trig form, which is what I'm going to be showing you today. And then there's something called polar form, which is what you'll learn next year. And it builds off of this idea of trig form. All right. So now remember, if I was to plot this complex number, so I'm going to do A in black. So if I was to go over 1, up 1, that would be right there. And I'm going to do B, kind of this reddish color. So that would be -3 up 0. That would be that point right there. And then C, going to do in this blue, is going to be over 4 down 5, which is this point right here. And then I'm going to do D in kind of this pink color. It's -2, -3. So this point right here. I don't like that color as much as I thought I would. I'm going to do this purpley color. There we go. I like that one a little more. All right. So I'm going to start with black. So the first thing, we're going to find the trig form of this. So the first thing we need to find is the length of that. So this is 1, that's 1. So this is going to be 1 squared plus 1 squared. So it's just going to be the square root of 2. Right? So that's the length. So when I write trig form of a complex number, I'm still going to write the square root 2 out here. But now I'm just going to pull it out because remember how it's both in the x and the y? So remember how all of these are the x coordinates, all of these are the y coordinates, because this is my y-axis, this is my x, this is my real number axis. Some of you remember this, some of you don't. It's okay. We'll get there together. It'll be okay. All right, so we get the square root of 2 here. And then this is going to be just like before. We're going to have the cosine of my theta plus, and now this time we're going to have I sine my theta, okay? And this is going to be my r, or the length of that line, okay? This is how you write trig form. So now we're going to do, we have to find this theta right here. So I'm going to do inverse sine. So second inverse, and we're going to do inverse sine of, now opposite, or actually I'm going to do inverse tangent because I'm lazy. So we're going to do inverse tangent of, now do you see why I'm doing inverse tangent? Because I know this number and I know this number. So I can do 1 over 1. Haha, I like that. Oh, where'd my calculator go? There it is. So I'm going to do 1 over 1. And I get 45. Oh, that's nice. So then this is just going to be the cosine of 45 plus I sine of 45. Notice that I didn't have to do anything special because it's already making an angle. Got to figure out what I want to do this angle with. Nope, I'm using that color later. Let's do it this one. I'm making an angle with the positive x-axis already. All right, so now this one over here, if we look at this, this has an x value of 3 and a y value of 0. So this would be 3 squared plus 0 squared. That's just 3. The length of the line is 3. That's great. So then we put 3. And then we're going to have cosine. And I'm going to do radians this time. Do you guys remember what the radians is for halfway across the circle? So what's the radians for that? You're right, it's pi. So I'm going to do cosine pi, I sine pi. That's kind of cool. All right. So then let's do my blue one. So my blue one is all the way over here. Okay. And we're going to do that reference angle again. So we've got this length here. So this is 1, 2, 3, 4, 5 in length. And then we've got this length here, which is 4. Okay. So I do 4 squared plus 5 squared. This one I actually have to do because my brain doesn't know it off the top of my head. So that's 16 plus 25. That'd be 35 plus 6 is 41. So then if we take the square root of both sides, we end up getting c equals the square root of 41. So now I know this is the square root of 41. And then inside the parentheses, I'm going to have cosine and sine. So let's do cosine of whatever it is plus I sine whatever it is. Now this one, we are going to have to do a little bit of math because we're going to have to find this angle from the positive all the way around to the blue. So we're going to have to take 360 minus this angle, or 2 pi minus that angle. I'm going to do 360 because why not? Okay, so we're going to do inverse tangent again because I already have those numbers. It's going to be 5 over 4. So I'm going to do inverse tangent of 5 over 4. And I get that, but remember, that's what I need to subtract from 360. Now, hopefully you guys know that if I subtract 360 from that number and I get this negative number, it's actually positive if I flip it around. So then this would be 308.66. All right, if you haven't tried one on your own yet, please go ahead and give it a shot. You deserve this. You owe it to yourself to try this on your own. Okay, so this time I draw my reference triangle. So this is now a distance of 2. This is now a distance of 3. So then I do 2 squared plus 3 squared equals c squared. So that's 4 plus 9, that's 13 equals c squared. So then we end up with c equals the square root of 13. So then I have the square root of 13. And then I'm going to have, now remember, we're going to have to add whatever we have this time to 180 to get our reference. I mean our actual angle, not just our reference angle, okay? Oh, this is square root 13. So now I'm going to do inverse tangent of 3 over 2, because it's always opposite over adjacent. And I get that. Now remember, I need to add that to 180 because it's past the line of 180. And I get 236.31 degrees. So then this would be cosine 236.31 plus I sine of, and I'm going to do it sideways, 236.31. Okay, there's complex numbers in trig form and points in trig form. If you notice, tangent inverse is a little easier than sine inverse, so I kind of wish I'd started that from the beginning, but here we are. All right, if you have any questions, please leave comments below. Love you guys so much. Have an amazing weekend.